Hello guys, welcome to the channel. I hope you all are fine and doing great. So today we are going to discuss this fill the tank problem of GFG. So let's move on to the problem guys. So guys, here what we are given n water tank, okay, which are connected and each ith tank has capacity cap I. Cap is a array given to us, okay, and we are given a edge array where the ith element of edge array means edge I0 and edge I1 are connected, means there is a edge between I0 and I1, okay guys. And now what we are doing, we are selecting our source node and we are giving some amount of water in it, so that each of the tank will contain the water of cap I. Okay, like here capacity of each the nodes are 1. So after having the water to each node, the every node should contain at least this much water and extra water should be wasted. Okay, like here what we are given, the when the tank is filled means the ith node is filled, it contain the cap I amount of water, the excess amount of water evenly flow connected tank. Okay, if there are no connected tank is it will just wasted out. Okay guys, so and the total amount of water given to us is 10 raised to the power 80. Now what we have to do, we have to find out the minimum amount of water we should given to source node S, so that each of the ith node contain cap I amount of water. Okay guys, so first of all we will just see this example, just it is reconnecting. Okay, bold marker we are taken, it is 1, then it is 3, then it is 2, then it is 4. This is the tree structure given to us initially. Now the minimum amount of water according to answer is 5. It is 5. Now we will understand how, and the capacity of each of the nodes is 1. Okay guys, so we are given 5 water to it, amount of water 5 to it. Now it will consume 1 water because the capacity of 1 is 1, so it will store its cap I water, means cap 1 is equal to 1. So left water is 4, means we have 4 extra unit of water. So what it will take, it will see I have 2 edges, so what it will do, half water it will give to this, means 2, and 2 amount of water gives to this. Number of child it have, it will give evenly. Here it is written, it will distribute water evenly. Okay, evenly flows. Okay, means the equal amount of water flows. Now here too it will store one amount of water. Now one amount of water we are left, this one amount of water just come out of it and just be tested. Okay, so now these two water we have, so what it will do, 2 will take one amount of water, 2 will check one amount, and left amount is 2 minus 1, that is 1. It has only one child, so it will given one amount to this. Now 4 will consume this one amount, left amount is 0. So you can see if we given 4 amount of water, this is the minimum amount. We can given more than 5 as well, but the minimum amount we required is 5. Okay guys, so now let's see how we will proceed to this problem. Okay guys, the one way of doing this problem is using binary search. We know the minimum amount of water we have to pour is 1, because there is at least one node and the minimum capacity should be 1. Now the maximum limit is 10 raised to the power 18, 10 raised to the power 18 as it is given to us. Then the maximum amount of water available with city corporation is 10 raised to the power 18. So what we can do, we can find out the mid of this L plus R by 2. Okay, the mid of this. Now searching, if we given mid amount of water, then it is possible. If it is possible, then I will decrease R, else while I will increase my L. Okay guys, this is one way of doing this problem, but we are not using this way. We just solve it in n o n way. Using binary search, it will take n number of nodes or number of tank, and log s. S is total, sorry, not s, this is R, means, or you can say 10 raised to the power 18, because the maximum search space is this. Okay, this is for the total binary search time limit we need. Okay guys, but will do it in on. We will just see a DFS traversal and complete this problem. Okay guys, so what we will do, I just erase this all, as I am going to tell you what I will do. This is tree given to us, we don't know how much water we need. Okay guys, so what we will do, we will start from source node. In this case my source node is this one. Okay, I just change color to purple as it is dark, so look good. Now we will start from here. So then I will do DFS. Okay guys, just then I will do DFS. Now I will go to 3, I will to 2, means I will try to find out how many nodes, how much amount of voter the children of 1 need in total. Okay guys, so first it will go to 3. Now 3 will say in my left amount I don't need any voter, so requirement is 0. In right side I don't need any voter, so requirement is 0. So 3 will say my children totally required 0 amount of voter. Okay, so 3 will say my children requirement is 0 plus its requirement, that number of voter units 3 node, his node required is 1. So total amount of voter we required in this node is 1. Okay guys, I hope you will understand. I will tell you, I will explain you. So it will say, it will return 1. Now what is this one? This one means in left side of 1 we required only 1 unit of water. Okay, the every node will satisfy if we give at least one amount of water to it, or maximum. Okay, we can give 1000 lakh crore any amount of water. The minimum amount of water is need is 1 in the left side part. Okay guys, I hope you all understand this. The children of 3 required 0 unit. Now children of 3 required 0 unit. Now 3 already required, also required some unit of water, so total is children of 3 plus 3. So this left side required 1 unit of water. Okay, so from left side it will call just I require just 1 unit of water. Now call come to 2. Now DFS call come to 2. Now from 2 it will go to 4. Now from 4 it will go to right, it will go to left. Okay, so we can say the children of 4 required 0 unit of water. The children of 4 required 0 unit of water because there is no children present. So 4 will say, okay, my children require 0 unit of water, and I require 1 unit of water. So total water this tree required is 0 plus 1, that is 1. Okay, 0 plus 1. Now I will say 0 plus 1. It children required 0, it required 1. So total amount of water it required is 1. It will say 1. Now this one means the children of 2 required 1 unit of water. Children of 2 are saying if you give me 1 unit of water or maximum I will satisfy, but the minimum amount of water I need is 1. Okay, now 2 will say okay, my children required 1 plus 2 itself require 1 unit of water. 2 itself require 1 unit of water. This will become 2. So the total need of this tree will become 2. It will return 2. Now what this 2 means? 2 means that 2 means to 1 that if you give 2 units of water to its right side, then all the nodes are satisfied. 2 and 4 are satisfied. Okay, this is 2. So it will gives is 2, means give 2 unit of water and I am completely satisfied. Now one will say because it have to distribute water evenly. Where is evenly? Yes, this is evenly flow. Evenly means the equal amount of water will flow from left and right side. Okay, it is not like that. Here we will give 1, here we will give 2. No, we will give X amount of water here, X amount of water here. Okay, unless this becomes just a sum problem, we just return the sum of all capacity array. Okay, so now one will say okay, my left side need 1 amount of water, my right side need 2 amount of water, so maximum amount of water I need is 2. So I will give 2 amount of water to both sides. So here we can say we will give 2 amount of water here, 2 amount of here. So here we require only 1, so 1 amount of water being wasted here. Okay, 1 amount of water being wasted here. So now guys, one will say how many what amount of water. Just a minute, I just again change the color to make it better understandable. So one will say my children totally require 2 amount of water and total number of children is 2. one children required two amount of water. Total children is two, so total number of water required by children of one is four. So one will say, okay, my children required 4 unit of water. My one itself require 1 unit of water, so total water I required is 5. Okay, children required 4 unit of water, two here, and this 4 unit contain means all the nodes are satisfied and water can be pasted as well. Okay guys, so one will say, okay, give me 5 unit of water. 1 unit I will consume. Okay, 1 unit I will consume 1 unit. Two will go to my left side, two will go to my right side. Now three will say, okay, I will consume 1 unit and other 1 unit will be wasted. Now two will say, 1 unit I will use, 1 unit I will send to four. Now I don't know what four it with this 1 unit. It will wasted one or what. Okay, now four will say, okay, I will use one, I left with zero, so I am completed. So only 4 unit of water I required. So here you can see in O and time we are solving the problem. What we are doing? We are doing bottom up. From source node, we are going to each leaf node, and doing bottom up in each iteration. Okay, guys. So now let's see the code. This is the complete. I think. Okay, guys. Now what we are doing? We are making. We are given edge. Okay, we are given edge like 1 2 are connected, 2 3 connected. Okay, and we don't know whether these edge are in order or not. Suppose we have given 1 lakh, we have total 1000 edge. Okay, now first edge is this, then 2 to 3, and other like 1000 to 100 to 100, 100 to 10 nodes. This is a edge. Now I again give 1 to 15. 1 to 50 is a edge. So after this I also want to DFS 50 because 2 and 50 are children of my 1, but I cannot. This is my edge array, so I cannot do so. So what I will do, I will make a array V where 1 will put 2 and 50, means 2 and 50 are connected component. 2 will store 1, means 1 is connected component to 2. 3 means 3 is connected component to my 2. Now similarly 10 will contain 100, 100 will contain, means all connected component contain my vector. I will make a vector of n plus 1. Why n plus 1? Because n is the total number of node is given to us 4, and here you can see maximum number of node I can have is 4. So n plus 1. Now for all the edges, I0 means first node connected to I1 means second node, I1 connected to I0. Okay guys, and here one more thing, the total amount of water I required always should be less than or is equal to 10 raised to the power 80, else while we cannot satisfy the answer. Okay, it should be always less than 10 raised to the power 80. Okay guys, so here we are taken a bool variable possible, means it should be always possible. Okay, it should be possible always, or we cannot use this. We should not use this. Just a minute, I am just checking whether it is possible. That if without post variable it is possible, then I just remove the variable. Compilation error. Okay, no problem. Oh, I need to declare it because I am passing it in a function. Correct output. I just try to submit it. Yeah, I think it is passed. Okay guys, so I just remove post variable. No need of possible variable, I think. Okay, because I am already giving -1. So possible variable I will require delete from all. Okay guys, so now we are taken ll required. Ll means long. Okay, I define, instead of writing long again and again, I just define it as ll. Now ll means long. Here I read ll required means ll long. Req means required amount of water total from source node to my all node. I passing a DFS. V is my raw vector. Raw vector in this is an array of vector type. Okay, you are thinking, how can I push back? This is a vector in type array of vector in type. It contains square bracket. Okay, more about it you can read on GFG or Stack Overflow. This is a array of vector in type. Okay, so I can store a vector int in each ith position. Okay, now for v S is my source node, parent of S is my -1, and cap. Okay, as you can see many solution where on time space complexity is used, but I am solving it in on. Okay, this is compulsory. This is compulsory space that I need. Without it, I cannot solve it, or else while it will go to n square complexity. Okay, so I am solving on. Okay, without using any distributed array or something. Okay, now from V S -1 capacity, this is my array given to me. Now what is my this DFS vector? My current position, my parent, and my capacity. So guys, now required is equal to children. Required and children, two thing I am using, required and children. Now what is this required and children? Require is the number of amount of water, like in left side. I just increase the thickness. In left side I required 1, in right side I required 2. So required contain the amount of final water means 2. The here can be two nodes, one required x, one required y. A required contain y amount of water, the maximum amount of water a particular children of a node need. Okay, initially it is 0. Child is the total number of child node current node have. Then for all the ith node, then I means all the neighbor node of v current. V current contain all the neighbor node, and if I is not is equal to parent, why it is I am telling you. This is this is this is suppose my current is this, my ith is this, my parent is this. If from current, I go to parent, then from parent I come to current, then from current I am going to parent, then again, then it will make a cycle. So what I will do, but I will go to current, and if the ith node is equal to my parent, then don't go to parent, because from parent I am going to current. Okay, now for current this is parent. Now from current we can go to I, but suppose here one more node I. Okay, this is also I, this is also I, this is also I. We cannot go here because this I is equal to parent. We go here. When we are doing DFS in this I, then this ith became my current, this ith became my current, and this current became my parents. Okay, this current became my parent because the parent of I is current. Okay, I hope you understand. Now this I is not is equal to parent to reduce the hesitate vector complexity, space complexity, and uh, and to avoid the cycle, graph cycle. We are increment the child, means we are teaching a node which is not is equal to parent, means it is the child. When we are come to here, we will increase child plus plus. When we are come to here, we will increase child plus plus. Okay guys, so child plus plus. Now CS requirements, the child required, like here, what is here, like from 1 we are going to here, it required 1 unit, it required 2 unit. Child required is 2 and 1 separately, and it is required initially it is 0. Initially this required is 0, means it is the complete requirement of these children. Now child required is particular, like for this it is 1, for this it is 2. Okay, child required is 1, then it is 2, and required is maximum of this 1 and 2. Okay, and if my child required is equal to 1, I will tell how it will become 1. Okay, for now just comment it. Okay, child required water something, so required contain the maximum of required and child required, means is it's ith child required amount of water. So final requirement amount is the maximum of required and child required. Okay guys, now we are come out of it. Now from ith node, how much maximum amount of water we need, total number of child it have, and the required amount of water. Okay, for it the required amount of water is 2, child are 2, so total amount of water it required is this 2 into 2 plus 1. So total amount of water required, this is child requirement, this is its self requirement. Child into requirement, total amount of water required by its all children, cap current, sorry, it will become cap current minus 1, cap, because this is 0 base indexing and current is 1 base indexing. Okay, so requirement of ith node is current I minus 1. Okay, okay guys, I hope you will understand. Cap array is 0 base indexing, current node value is 1 base indexing. So the value of current is current minus 1 index in cap array. Okay, so the voter stored by current node is cap current minus 1, and if this value, this total requirement for ith node exceed 1e18 means 10 raised to the power 18, this is 1e18 means 10 raised to the power 18, then we just return minus 1 means it cannot possible to distribute voter. Okay, else while we return one, else while means it is possible, then what I will return child into requirement, total amount of requirement by its child. Now capacity of current minus 1 means the current node capacity. Okay guys, now why this I comment out, if somehow the ith node the requirement of its children became so huge that it will exceed 1e18, then it will return minus 1, and if it is minus 1 then it means we cannot completely satisfy all the nodes, so we just return minus 1. Okay, and at last if my requirement is equal to minus 1, okay, or we don't need to write it, because if my requirement is equal to minus 1 it will return minus 1, else while it will return the amount of water we need. Okay guys, this is the code, something bottom up, not so much complex, but the question statement is just very boring and dreadful, you can say. Okay guys, so you can see all the 13 test cases pass out. I hope you all understand the approach. On time complexity, O1 space complexity approach, this is. So guys, if you have any doubt then just comment out, I will try my best to explain you. Please subscribe the channel, like the video, and comment out if you understand the approach, as it will motivate me to make more these type of videos. Thank you for watching this guys. Please subscribe and check out my channel for more these type of videos. Thank you for watching this guys. Stay tuned.